All right, in this section, 12.2, we're going to talk about how to find the derivative of a product or a quotient. A product is when I have a function where I have two things being multiplied that both include variables. We haven't ever seen anything like that. Or if we have, we've FOILed it out and we've changed it to look like a function that we do have rules for. And a quotient is when I have a function that has a variable in the numerator and a variable in the denominator. And we haven't seen any of that before. Well, if we have, what we've done is manipulated it, and we've either separated the fractions or we've brought the denominator up and made the exponent negative. We've had to somehow rewrite products and somehow rewrite quotients into problems that we do have rules for, until now. So we're going to talk about rules if we have a product or a quotient and how we can find the derivatives properly. Before we do that, I want you to look at these two problems. I've given you the problem x cubed, and I've given you the problem x times x squared. If you look at them, aren't they actually equivalent? X cubed is the same thing as x times x squared, but just written as a product instead of one term. But we know that the derivative of x cubed should always be 3x squared, right? So whether I separate it into a product, it's still the same value. It's still an x cubed. It should still have a derivative of 3x squared. But if I take the x times the x squared, this product, and I try to just take the derivative of each piece separately and then multiply them, do I get the same answer? Well, let me show you. If I take the derivative of x, I get 1. If I take the derivative of x squared, I get 2x. 1 times 2x is 2x, which you can see is definitely not the same thing. The point is, if I have two things being multiplied with variables, I cannot just take the derivative of the first one and the derivative of the second one and try to smash them together and try to multiply them. I don't get the same answer. What we have to do is what we call product rule. The product rule says we take the first times the derivative of the second, which in this case would be 2x, plus the second times the derivative of the first. The derivative of the first, x, is just 1. X times 2x is 2x squared, and 1 times x squared is 1x squared. I have like terms now that I can combine. 2x squared plus 1x squared is 3x squared. Ah, and look, now I've got the correct answer. So anytime I have two terms being multiplied that contain a variable, you cannot just take the derivative of each of them separately and then try to multiply them. You do not get the same answer. What you have to do is use what we call the product rule. If you have two functions being multiplied, the only way to properly take their derivative is doing the first function times the derivative of the second function, plus the second times the derivative of the first. Make sure you memorize this rule. So add this to our list of derivative rules. You need to make sure that you not only know the rule, but you can apply the rule to take derivatives of all sorts of problems. I think I even might have some derivative rules practice in Canvas that you can print off and practice and practice and practice so that you can memorize the rules so that we can then apply them. Let's do one example, A and B, of example number 1 to practice this product rule. You might notice in example number 1, it asks us to find the derivative, and I have two pieces being multiplied, right? Because the parentheses are right next to each other. Now, this is probably a simple one where you could have just distributed and separated it into a bunch of different terms with plus or minus signs in between, and then taken the derivative. Or you might not be able to simplify. They might be a little too complicated for you to do that, and then you have to use the product rule. So let's practice using the product rule. Product rule says, remember, the first, which is our 2x plus 3, times the derivative of our second. So the derivative of 3x squared is 6x. Plus the second, which is our 3x squared, times the derivative of our first. The derivative of 2x is 2, and the derivative of 3 is 0. So really the derivative of my first is just 2. Now, I do have to do a little bit of distributing and combining like terms. 6x times 2x and 6x times 3 is 12x squared plus 18x. And then 3x squared times 2 is really a 6x squared. I can now combine my like terms, and I end up getting the derivative as 18x squared plus 18x. But I had to do the product rule there. Well, I guess I didn't have to do the product rule. Remember, we could have distributed the 3x squared through first. You can do that now, and then take the derivative and see which way you like best. But we should still get the same answer either way, right? Okay, but look at B. B is a little bit harder to distribute or FOIL because we have some radicals in there, right? So let's go ahead and do product rule here. You notice that we have two terms, two pieces, right, that are being multiplied together that both contain a variable. I cannot just take the derivative of the first and the derivative of the second and smush them together. Doesn't work that way, unfortunately. So let's go ahead and use the product rule. Before I use the product rule, I see that square root, and I'm going to go ahead and change that. Remember, as soon as I see that square root of x, I'm going to change it so that it says x to the 1/2. Now I'm going to do product rule, where it says the first times the derivative of the second. So my first is my x squared to the 1/2 plus 3 times the derivative of my second, which is 2x minus 5, plus the second, which is my x squared minus 5x, times the derivative of the first. The derivative of my first is 1/2 x to the negative 1/2 plus 0. Now, I still do have to do a little bit of FOILing and distributing here. Are you ready? So we have an x to the 1/2 times 2x and an x to the 1/2 times 5. Remember that when we're multiplying, what do we do with the exponents? We really add them together, right? So my exponent on my 2x is a 1, but if I'm going to add it to a 1/2, I need it to be a common denominator. So can I really call it 2/2? So when I distribute it, I end up getting 2x to the 3/2. When I distribute the x to the 1/2 to the negative 5, I end up getting negative 5x to the 1/2. I'm going to distribute the 3 to the 2x, that gives me a 6x, and a 3 to the negative 5, that gives me a negative 15. So I just FOILed with my exponents. All right, for the second piece, I'm going to take this 1/2 x to the negative 1/2 and do the same thing. I'm going to distribute it. And remember, when we distribute, when we multiply, we really add the exponents. So instead of calling this a 2, can I really call it 4 over 2 so that I have a common denominator? When I do that, x to the 4/2 times 1/2 x to the negative 1/2 is really 1/2 x to the 3/2 using my fractions and my common denominators. When I distribute my 5x to my 1/2 x to the negative 1/2, negative 5 times 1/2 is negative 5/2, and x times x to the negative 1/2 is x to the positive 1/2. Make sure you practice your exponent rules. Now I have some like terms here. I have a 2x to the 3/2 and a 1/2 x to the 3/2. So again, I can combine those, but I need to add my coefficients together. So instead of calling this a 2, again, can I call it 4 over 2? So that means my 4 over 2 plus my 1 over 2 is really a 5 over 2 x to the 3/2. I also am going to do the same thing with my negative 5 x to the 1/2 and my negative 5/2 x to the 1/2. If I think about my negative 5 being a negative 10 over 2 x to the 1/2, and I'm going to subtract 5/2 x to the 1/2, I really have a negative 15/2 x to the 1/2, right? I have a 6x that has no other like terms to it, and I have a negative 15 with no other like terms to it. So my derivative with all my like terms combined and positive exponents looks like this. I know that was kind of tricky, especially with distributing and having those different exponents with different common denominators, so make sure you practice that one. You may need to pause the video, replay it, and practice it a few times before you understand what happened there. But make sure you understand how to use the product rule, because we're going to be doing this for the rest of the class. So make sure you practice that rule and you can apply that rule.